Hey 8th graders, we are starting lesson 2 in your iReady book, which starts on page 15. I'd like you to make sure you show this parent letter to your family members so they know what you're working on, and this also really tells you all the information for the week on this one page if you ever want to preview it. I want to go over just quickly here what we went over last week because it lists it for you right here. So last week we learned about transformations that do 3 things: slide, reflect, or rotate, but they do not change the size or the shape, and that's why we call them rigid transformations, because the transformation does not change the size or the shape. The shape stays the same. And this week all we're doing is we are putting that shape on the coordinate plane, and we're going to start talking about the points. See how over here it's got the points of the vertices. Remember, vertices just means corners. So go ahead and read page 15 with your parents, and then you're going to work on page 16 just really quickly. Nothing fancy unless you want to get fancy. Art is always fancy, but see if you can make, as an example, use rigid transformations to make a neat pattern like they've done up on this example up here. But there's 2 spots where you can make a pattern using those figures. But we are going to start together on page 17. And the first thing that we're going to do here is we're going to see if we can figure out how to translate this triangle, our original triangle, into an image based on the criteria. And we are also going to talk about what that does to the points, aka the vertices. Remember, vertices means corners. Okay, so Roberto here uses a computer design to make stickers. He draws triangle ABC in the coordinate plane as shown, and then he translates, remember that means slides. Let's put a little note there for ourselves. Remember, we put a lot of notes in our book so that we don't need a separate notebook. So the translation, remember, that's the slide. Not going to flip, not going to rotate, just slide. And he's going to translate ABC, whoop, wrong tool. There we go. ABC 5 units to the left. 5 units to the left. And this is going to form our image, which will be named triangle A prime, B prime, and C prime. See that little tick mark at the top? That means you call it prime. It means it's an image. What are the coordinates for the vertices for triangle A prime, B prime, C prime? And I'm going to put myself a reminder here. Vertices means corners. Okay, so all we're doing here is we are taking our original triangle ABC and we are translating it 5 units to the left, and we have to say what the new points are for the vertices. Okay? And it gives you this whole space to do it, but the coordinate plane's up here, so I'm going to do what I think makes the most sense to me, and I'm just going to count 5 units to the left and put the new points. So we've got C right here. You're going to go 1, 2, 3, 4, 5. There we go. There's C prime. We're going to do the same with B. 1, 2, 3, 4, 5. There's B prime. And 1, 2, 3, 4, 5. There's A prime. And then I don't want to forget to connect them. It's not much of a triangle without sides. And then the question was, what are the coordinates of the vertices? So we just have to now look and figure out what they were. So we've got A prime is, let's count it out. Let me get a different color. So remember, we do the horizontal first because X comes before Y in the alphabet. So we are at -1. And then it's at +8. Right there. Okay. Then we've got b prime is going to be, it's also at -1, but it's at +4. -1, +4 for b prime. And then for c prime, we've got it is at -4, and then it's at +5. There we go, and that is the whole thing. Basically, we're just going to look at a couple methods now for doing that. So, if we go down to page 18, question 1 says, what are the coordinates of the vertices for triangle A prime, B prime, C prime, and how do you know? So let's see, what can we say here? I'm not going to make you rewrite them. There, coordinates are up there. Since you're not really going to probably turn this page in, you can indicate the coordinates are up there. But you do have to answer the how do you know. You must practice thorough math discussion. So, I know because I counted 5 spaces to the left, right? Yeah, I counted 5 spaces to the left for each vertices, each vertex in that context, right? Each vertex. Vertex is one, vertices is just the plural. It's not vertexes, it's vertices. Okay, looking ahead now in Roberto's design, triangle ABC, the original, transforms or maps into a triangle A prime, B prime, C prime. This means that the vertex of A corresponds to vertex A prime. They're corresponding, they go together. One's the copy of the other. Vertex B corresponds to vertex B prime, and vertex C corresponds to vertex C prime. So add that word to your vocabulary if you didn't already have it. Corresponds. They correspond to each other. And it says A blah 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 is read as A prime. I already told you that. Naming an image. Remember, image means the copy, the new one. Using prime notation helps identify the corresponding vertices. So if we had changed it, instead of triangle ABC to A prime, B prime, C prime, if we had changed it to now triangle, I don't know, CAT, then you'd have to figure out for yourself which vertex goes with, corresponds to, sorry, I'm already not using the word, which vertex corresponds to which. But since they have the same name, just with prime notation, it's very easy now. So let's look at this table of a new point. So here's the original point, and it has been translated 1, 2, 3, 4 times. And what happens when it translates 2 units to the left? Well, what changed? That changed, but the y stayed the same. Now it's translated 4 units to the left. Once again, the x changed, but the y stayed the same. Translated to the right, x changed, y stayed the same. Further right yet, the x changed, but the y stayed the same. And I can illustrate that for you right here. So I'll make a little coordinate plane, just a little one. And if it's changing to the right or left, I'll use a different color. If it's changing to the right or left, it's not going up or down, so the y is not going to change. Just the x's are changing because it's going left to right. Okay, so how do the coordinates of a point change when it's translated left or right? The x value changes, but the y value does not. And don't forget to pause or rewind if I go too fast. I'm going a little fast because I don't want this video to be terribly long, and because you have a pause button. So if you need to use your pause button, use your pause button, because I'm going to move right along here. Okay, so same deal here, except this time we're going up or down. Okay, I'm going to draw another little coordinate plane for you. And now this shape is going up and down. So this is not going to change. The x is not going to change this time. The y is going to change because it's going to go up or down. It's not going left or right. So if you look here, the original is, I want to go back to my original colors. The original is 4, 8. And the 4s, the x's this time all, I did the opposite colors again. The x's this time all stayed the same, but the y's are changing. If it goes 2 units up, then this is going to go 2 units up. If this goes 4 units up, it's going to go 4 points up. If it goes down, this goes down by 2. If it goes down by 4, then this goes down by 4. So let's copy our answer from up here. Let's see, will it let me do it? Does it let me copy? Da, 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 da. I wonder. No, maybe not. I'll just have to rewrite it. It's the opposite anyway. The y value changes, but the x value does not. Oops, that's an A. There's no A in does. Yay, we did it. Okay. Okay, so now let's figure this out. What are the coordinates of the point, just one point, not a whole figure, point xy, translated 5 units down? Explain. Well, what happens if we translate down? Let's look at our example up here. Let's look at this one. This one went 4 units down. And what's the difference between this one and this one? The x stayed the same. So the x stays the same, but the y went down by 4. It went 4 units down, so the y went down by 4. This one's going 5 units down, so the y will go down by 5. You could even put this, if you wanted to, as an actual point, x, comma, y minus 5. That would be fine. Okay, so now your assignment is, I want you to look at page 19, and we're reviewing what vertices are. A vertex, so here's the singular, vertex, and then the plural right here, vertices. And you just fill out what you know about vertexes and vertices. And then, I think that's the last page, is 20, yeah. So just pages 19 and 20 need to be submitted to Canvas, por favor. And I will see you tomorrow for session 2.